Again, thank you all for joining. My name is Nathan Puccini. I am a marketing manager at Data Science Dojo. And today I have Zed Ahmed, one of our own data scientists, 5-time Azure solution architect. And Zed's going to be taking us through fine-tuning Llama 2 on RunPod. So Zed, I'm not going to try to explain those things. I'll let you go ahead and do that. But again, if you have questions and you're in Zoom, use that Q&A tab. If you're outside of Zoom, whatever chat you have available to you, they will get pulled in for us and we will see them. So Zed, why don't you go ahead and get going?
Thank you for the introduction, Nathan. And without further ado, I'll start sharing my screen. Just let me know if my screen is visible.
Looking good.
All right. So let me start with the introduction. So I'll be walking you through the demo of how we can use open source models like Llama 2 and then fine tune on our own data set that I have prepared it before this webinar. So this is going to be very interesting because most of the companies nowadays are looking towards how we can utilize these open source models for our own use cases. So if that sounds interesting, let's get straight to the agenda of today's webinar. So first and foremost is we'll be talking about the open source community, the LLMs we have in our open source. And you guys must have heard about this HuggingFace platform where most of the open source LLMs are there. So we have this leaderboard in the HuggingFace where like the top, I'll be showing that leaderboard in a couple of few minutes. So that leaderboard has all of the top open source models, and Llama 2 is undoubted, like there is no doubt that it is on top of all of those open source large language models. So Llama 2 has been, it's an open source LLM that was launched by Meta, previously called Facebook. So then we'll be jumping into why fine tuning is needed. Why do we really need to do fine tuning? And there is another question that companies ask: is fine tuning is required for their use case? Is that maybe there is some problem with data protections, maybe there are some compliance issues. So company wants to shift because we all know that OpenAI does have all the access to the data. What if we are not paying for a service, then guess what? We are actually utilizing ChatGPT, but we are training the model because ChatGPT is storing all of the data. So if the company has some precautions that it cannot place its data on ChatGPT and we cannot public the data, so fine tuning plays a major role in that. So this is something that companies are looking forward to. Then we'll be talking about how we can prepare our data sets for different open source large language models. Then we will be discussing a specific use case of fine tuning, that is instruction fine tuning, and how it is different from supervised and unsupervised fine tuning. After all of this, we'll be going towards the use cases of fine-tuned models, what we can do after fine-tuning an open source model and how we can utilize that particular model in production. And after this theoretical discussion, we'll be going towards a hands-on exercise on fine-tuning Llama 2 and RunPod. So RunPod, it's a platform that provides the compute resources so that we can fine-tune our large language model on our own data set in their environment. So I'll be walking you through the RunPod architecture and platform. So we'll be uploading our notebook and data set in that particular platform, and you guys can perform the similar task just right after the webinar. So this was the brief introduction and the agenda of today's webinar. If that sounds interesting, let's deep dive into the foundation models and let's get started. So first and foremost, let's talk about what are foundation models. So before diving into this complete architecture, we must have this understanding of what large language models are. They are just statistical models that are built on top of large public data. They are pre-trained on historical data, and they are very fluent in conversation in using natural language processing. So they can talk like humans using NLP. So LLMs are just, you can say they are built on top of a public data. So you guys are must aware of ChatGPT. So ChatGPT is a foundation model that is built on top of public data. So there are other competitors of OpenAI as well. We have Anthropic. You must have heard about Claude 2 that has 100K token limit. And then we have HuggingFace, we have Replicate, and there are other cloud providers. They provide compute services for this architecture. We have AWS, we have GCP, Azure, and other competitors as well. Now coming towards these platforms, we have RunPod. RunPod is a platform that provides compute services, so we can run an open source large language model on it, and we can perform our inference queries through this platform. So that's all about the commercial LLMs that are available. So let's understand the evolution of ChatGPT. So there are 6 phases of what we now see. ChatGPT was once a transformer, and transformer was the backbone of this transformer was this particular paper, Attention is All You Need. So it was in, so when this paper was published, the whole domain of NLP was changed. So transformers had an encoder and decoder architecture, but there were few implications that were implemented in transformer architecture that created a generative pre-trained model that created, after this transformer, this was the discovery of GPT. Then there comes this GPT-2. It was a multitask training model. And then we trained this GPT-2 and GPT-3, even a bigger model. And then we trained it on instructions prompt training. And what is that? So consider an instruct GPT as an agent. We have pre-trained it on question and answers. So how does this pre-training work? We have provided a question along with the answer to this question. And so in this manner, an instruct GPT was increased the human interaction. It has increased the human interaction, and we were able to communicate with these chatbots easily. And then there comes this ChatGPT that is built on top of instruct GPT, but there is another, like you can say, a feature in it that is human feedback. So I have used ChatGPT quite often. So one thing that we are doing with ChatGPT is we have involved reinforcement learning in this. Reinforcement learning in this with human feedback. And what is that? We can rate the answers we are getting from ChatGPT, whether it was a good response or whether it was a bad response. Either we can upvote the response or we can downvote the response. And what does it actually helps us in doing? Because it helps in the reward function, because we are rewarding the model according to the response it is getting us. So it is sort of a closed loop where human is involved. So this is the difference in the evolution of ChatGPT, how it all started from the transformer and then came along to this particular model we are interacting with today. Now, moving forward towards the open source community. So we have a large number of large language models that you must have heard about Red Pajama, MPT-7B, then there is Vicuna, and there is Llama 2. We have Llama 2 in different variations. We have 77 billion, 30 billion parameters. So there is a wide variety of large language models that are open source, and we can utilize them in production as well. So it will what will be the use case of these open source LLMs? There will be a cost cut. So we don't have to pay a huge amount of money to OpenAI for all of our queries. All we can do is just utilize the open source LLM and fine tune it according to our use case, fine tune it according to our own data and use case, and we can use it into the production. And we can use it in the production. So this is the particular scenario we are going to follow on today. What I'm going to do, I'll be taking an open source LLM, and I have the data of I have the data set. So I'll be fine tuning this particular LLM on this data set I have. And then I can ask a couple of inference questions. I can ask multiple queries, and I can even deploy that fine-tuned model into production. So these are some steps that we are going to talk about. Now moving forward towards this Hugging Face leaderboard that I was talking about. So there are a couple of models. We have Llama 65 billion, we have Llama 30 billion, then we have a stable Vicuna, Llama 13 billion, and we have Alpaca, and then a couple of more models. So the reason for this Hugging Face leaderboard is whenever there is an open source LLM, what they do is they evaluate that particular LLM on the test and training data, on test data sets, and there is this average accuracy score. We have these particular metrics, how we can evaluate our model. We can evaluate on 25 shot, 10 shot, and 5 shot. So there are a couple of different evaluation metrics we can evaluate our open source LLMs. So this is a pretty cool resource. The link is over here. We'll be providing you the slide deck as well. So you can go and look at this Hugging Face leaderboard. And if you have any questions up till now, you can always put them in the chat. I'm also looking at the chat. So once I'll get the chance, I'll reply to all of the questions. So if that sounds interesting, let's go to the challenges. What is the actual challenge? Why are we doing all of these things? So the first and foremost challenge is we have to talk about that most of the time foundation models, they have a lack of information. If you go and ask who won the 2023 chess championship to either ChatGPT, if it is not linked, I would repeat it, if it is not linked to the internet, or you are using a free version that is not linked to the internet, not connected, then it will hallucinate. It will only hallucinate because it does not know the context. The context is not set for the 2023 because ChatGPT was trained on 2021 data set. So what the response you will, once you ask this query to this model, the response you will be getting from this model would be, I'm sorry, but I do not have the access to real-time information. My knowledge is up to date only until September 2021. So this is the actual problem. So maybe you can use the ChatGPT GPT-4 that is now it is connected to the internet. So there is a lack of information, and let's take it the other way around. If we talk about if I ask about the Data Science Dojo Large Language Model Bootcamp, would it be able to answer it? No, because it has not trained on the recent data set. Until and unless it has this feature to search, until and unless, because in paid GPT-4 features, we have this ability for a search agent. It can go and do the Google search and just get the rest. and can get the response for you. So it totally depends on the use case. If you are saying, no, if I go and ask and it is giving me the right response, so you either you are using the paid version or your GPT-4 is connected to the internet. But the more important part is the data protection laws, such as companies, the data protection laws. This is one of the biggest challenge, I would say, because whatever you are communicating with ChatGPT, it stores the data, and it claims that it would be used in the further training of their model. So OpenAI does have all the resources to train on top of your data. So if you have general data, if you have compliance issues, you must have an open source model that is deployed in your own cloud. So after moving forward, let's understand more about this. If it does not contain the up-to-date or specific information related to Data Science Dojo, if I'm asking the questions about specifically Data Science Dojo, and I'm asking the ChatGPT that just whether their bootcamp is offering what courses the Data Science bootcamp is offering. What are those courses? And is it relevant for me? If I ask about the FAQs of the ChatGPT, so it won't be able to answer it. So the use case of this is we can fine-tune our model. We can fine-tune an existing foundation model, and we can train it on our own data set. Let's suppose these are the FAQs of my own company. If I talk about, since Data Science Dojo has recently launched this particular large language model bootcamp, if I have the data set of this particular bootcamp, so what I can do, I can fine tune an open source model and can train my large language model on top of my own data. So I would be able to query a couple of information from this. So what is the requirement of this? It would be a slightly lower cost, and we would be able to train a large language model on our own data set, and it would be completely private. So our data protection laws could be handled, and we don't have any compliance issues with that. So this is the actual rationale for why we need to fine-tune an open source large language model. So keeping these things in mind, we can jump towards how we can fine-tune an existing foundation model. So first and foremost thing is the preparation of your data set. And how we are going to do that? We can prepare our data sets. We can use a large language model that I'm giving this particular example because I have created an FAQ data set for a large language model bootcamp that we have launched a couple of months ago. So I have created an FAQs for that, and we'll be training our model on the question and answers for that. So what do we need? We should collect some examples, train the model on this, and we can enjoy the creative results from it. So this is the whole exercise we are trying to cover in today's webinar, that most of the times the whole part is just the security and compliance issues, because you guys must have heard about this responsible AI. The data protection rights are very much important for every other company because they have to be responsible about their large language model responses. So there should be a data privacy and there should be a security features. So in order to achieve all those things, what we can do, we can utilize an open source model, deploy it in our cloud instance, and pre-train that model on our own data sets. So moving forward towards the preparation of data set, we'll be starting with an FAQs question and answers. We'll be splitting it into test and train dataset. Then we have to worry about token limits because every open source model comes with a token limits. Claude 2 has a token limit. Claude 2 has a context window of 100K tokens. And there are other models that can deal with this amount of contextual data. Then we have to check about the data formatting because it should be in a, like for every open source model, there is a pattern. We have to follow that pattern for pre-training of our models. So we have to validate the formatting of the data before training it on our corpus of data. Then we have to also estimate the cost. How much amount of cost will it take for just doing it on the RunPod? It will take some $2 per hour. If we are using a compute, it really depends on the compute you are setting. So the cost estimation is very variable. So this is something you have to set your budgets accordingly. So let's understand what is instruction fine-tuning. Let's suppose we have this base LLM that is, I would say, Llama 2. And I would name it as 7 billion parameters because I'm utilizing the same instance of that Llama 2 model. So it is a quantized model. So we have 60 billion parameters. So we just quantize it to a 4-bit architecture. So moving forward, what actually I'm trying to achieve? I'm trying to achieve this, that my open source LLM should be able to answer these queries. What are the topics that are taught in the large language model bootcamp offered by Data Science Dojo? Who is the main instructor of this bootcamp? It will give us an output that Raja Iqbal is the main instructor of this bootcamp. Do I need to have a background in data science before joining this bootcamp? No, there are no prerequisites for this bootcamp. So these are some examples this is what we want to achieve throughout our fine-tuning, that our open source LLM that is not aware of this data, I'm just fine-tuning my model using this data. Now, after we have this FAQs data set, and once we have fine-tuned our model, we can utilize this fine-tuned model. We can save it. We can save this model. We can call queries on top of it. We can ask this model queries, and then we can also deploy it into production as well. We can also deploy this model into production. So these are some various features that we are going to do. Now comes this question, how we are going to achieve this particular use case. So there is always this prompt and completion we are going to give to our model. This will be what we are trying to do. We are trying to instruction fine-tune our model. And how we are going to do that? We are going to instruction fine-tune our model. And how we are going to do that? We're going to provide it a question that, okay, here is this question, that this bootcamp is of 40 hours. And it asks you can have a data set. You can have a data set that has a number of questions and an answers to those questions. The number of questions and an answers to those questions. And once you have trained your model on top of it, you will have a fine-tuned model that is trained on your own data. So this was the theoretical discussion about this. So let's jump to the hands-on exercise. I'll start sharing my notebook that I have already created for this. So there's this question that you're asking if you have any recommendations for creating this data set. Yes. So for every large language model, there is a slight difference in all the data sets patterns. So for an instance, let me share my screen and give you an example of how the data set looks like. So if I go and start sharing my screen. All right. So if you can look at over here, if I zoom it a little bit, just give me a moment. All right. So you can have a look at this. So these are the question and answers we are trying to use with our data set. So what cloud platforms do you teach deployment on? So this is the particular question. And then there is this answer. We cover deployment on managed platforms like HuggingFace, Azure, and AWS. So that's how you create your data set for your own, like for your own use cases. Do I need to have a coding experience in Python? So basic Python skills will be helpful to follow along hands-on activities. So this is the complete FAQs data set that I have created. And you can also create this, and it is in a specific format that is .jsonl. So this is the requirements of a Llama 2 model. Now going to our exercise, we'll be performing our exercise on this RunPod. It is an infrastructure which provides computes. A GPU compute would be provided to you once you have logged into it, and you can do this. You can this whole webinar would be recorded. You can follow along this exercise after the completion of this webinar. You can just watch this video and follow along and log in through this RunPod. Once you are logged in with your user account, you can just go to the secure cloud and just deploy any of this machine. All you have to do is just pick a machine. Let's say if I'm picking this one RTX A4000, it has 16 GB VRAM, 23 GB RAM, and 6 vCPU. Just go and deploy it. So once you have deployed it, it just takes only 1 minute to set up this complete machine. And you can also connect to the Jupyter Hub through this machine. You can run a Jupyter lab on top of this machine. And once you're done with this, you would be able to see this Jupyter lab RunPod. And I'm going to show you just it is redirecting to my pods. So once that is deployed, so you can just go to this connect option, and there comes this Jupyter lab. It gets ready in a couple of minutes. So now you can just go and connect to the Jupyter lab. You can upload your notebooks over here. You can upload your data set over here. It is a complete infrastructure for you to work on your requirements. So I have already uploaded my notebook over here. So let's run through it. So what I'm trying to achieve over here, I'm fine-tuning Llama 2 model over here. So first and foremost is I'm installing the prerequisites. I'm installing the libraries that are required. I'm installing parameter efficient fine-tuning library, bits and bytes, transformers, science, SciPy, and TensorBoard. And after this, once I'm done with installing these libraries, so I've already installed it because it takes a couple of minutes and we were short of time. So then you can import these you can import your data set. So I have already, like, you can utilize my data set as well. So it's on the HuggingFace Leaderboard. So I'll share the link with you with the data set. So this data set would be provided along with this notebook. So you can follow along this after this webinar. So you can import these libraries, and then let me remove them and I'll stop my annotation. All right. So there is this sequence that Llama 2 requires this particular prompt template. And what is this? This should be the starting case, and your question would come over here, and this would be the user prompt. This would be your system prompt, and this would be the user prompt. And there comes the model answer. So this is how I have also created my particular data set. if I go and show you guys, so in this particular manner, I have created this particular data set. So you can, so every open source model requires a validate data formatting so that it can pre-train its parameters on top of it. Okay, so let me remove these things. All right. Okay, so in this third cell, what we are doing, we are calling this model from Hugging Face. It is already on the Hugging Face. You can go and search about Llama 2 7 billion chat, and it is on the Hugging Face. And I am naming my data set over here. It is as the name of Bootcamp Q&A data set. So I am also creating a Llama 2 7 billion chat fine-tune model after this. And then there are some other parameters for quantize low rank adaptation and low ranked adaptation attention dimension. We cannot go into the intricacies and the details of this because it's a separate topic. What are the abstraction layers behind this fine tuning? How do we really quantize the model, and how do we really fine tune it by just dropping out some redundant layers in? So that's another topic. So we can discuss in our upcoming webinars. So this could be a fairly an hour of discussion on this. So what you have to really focus on, that these are the number of train epochs we are providing over here. And then once we run this complete, because it has a lot of intricacies and details in it, because fine tuning requires a lot of details of how we quantized a particular open source model and how we are dropping some parameters and layers and some abstractions. So I'm just giving you over here a brief overview how you can fine tune an open source model using your own data set. So once we have run this particular cell, let's come to this main part where we'll be loading everything and start the fine tuning process. So this is the fourth cell. So we are loading our data set. We are splitting it into test and train splits. And then there are some compute types. We are specifically mentioned it there that we will be using the 4-bit. And then there are some quantization techniques that we'll be using at bits and bytes through bits and bytes libraries. So after mentioning all the GPU requirements and all those things, we can run this particular line of code, and we are using parameter efficient fine tuning for fine tune our model. And it will take some time, and till then we can take some of the questions. And so Ankita is asking, is there any prerequisite requirement? No, you just so this cell has started working. So it will be training your model on 15 epochs. So till then we can take a couple of questions. So the only prerequisite is you just have to log into the RunPod. You will be providing you a data set, will be providing you a notebook. All you have to do is just log into RunPod, and it will take a couple of minutes. So you just have to mention the compute cost over there, and that's pretty much it. All right. So Anthony has this question: is this free? So training your LLM model on RunPod, it requires a fraction of cost, only $0.2 per hour. So just for if I go to any compute, so $0.2 per hour is like it won't take an hour to just do this. So I would say it's just a fraction of cost. So as you can see, it is on the 4th epoch right now. Adeshina, I hope I pronounced the name right. Is it to make the model user specific? Yes, exactly. That's the whole point. We are trying to make a particular large language model user specific for a particular requirements. Yes, this can also be run on Google Colab, but you have to take the Google Colab Plus version. This notebook can also run on Google Colab. I did try it on the Google Colab as well. How do different versions of Llama to 7 billion, 13 billion parameters affect training time? Yes, it does affect the training time because you can see from their name that one model is utilizing 7 billion parameters for the neural network architecture, and the other model is utilizing 13 billion. What we are trying to do, we quantize that model, that 7 billion parameter model, into a 4-bit. We are just removing the floating point accuracy and we are making it less accurate, but just let's say it is, what we are trying to do, we are doing that condensation approach that we use in principal component analysis, or we use in computer vision. We try to condense those parameters and train those effectively chosen parameters, and then once we are done with that, our model would be fine-tuned on our specific data set. Yes, Harry, you can try the Collab Pro to run this notebook, and it will affect. You can lessen the amount of epochs that we are trying over here, and it will work. So see, this is the loss, and this is the learning rate of this. So I have mentioned that I'll be using 15 epochs for this particular use case, and you can try different epochs for this particular one. Okay, yes. So there's this follow-up question from Sai. So he's asking, once we fine-tune a model by retraining using custom data, will all the learning that the open model did, like all the learning it has on pre-trained data, will it still be valid? Yes, it will still be valid. And there will be a point where your model would hallucinate you. Like if I ask a very difficult query over here, it won't give me the right answer just because I have trained it. So it also carries the pre-trained information that it was trained on, and it also combines both of the recent information and the information that it was previously trained on. So our training part has been completed. Let's try a couple of queries that we can ask to this model. So first and foremost, I'll go to the large language model bootcamp page, and let's see what are the some queries that came into my mind after just going to this bootcamp. So first and foremost, I'll ask what is the schedule of this particular bootcamp? How can I get, like, what is the structure of this 5-day bootcamp? So I can ask about this. Let me just go and put it over here. What is the structure of this 5-day bootcamp? So if we have another question, we can take a couple of questions because inference takes some time in open source models. Is it generally better to use multiple high-end GPUs that cost more but will complete faster, or go with a cheaper single instance lower-end GPU, but it will take longer, which is ultimately to lower cost? Is there a sweet spot and a general method to calculate this? Cyber Mage. So that's a wonderful question. I would say it totally depends on how do you optimize your cost, because there are various things that we can optimize our cost. Either we use, like I'm using a $6 per hour high GPU cluster, and I can train my model in just 10 minutes. So it will cost me less amount. And if you're trying to do it on a $0.2 per hour, and it takes you more than an hour, so it's totally depends on your calculation and your particular use case, that how much time will it take to fine tune and what would be the right optimum limit for it. So there comes this answer. The structure of this bootcamp is a series of lecture, hands-on exercises, and guest lectures. Each day covers a specific topics and builds upon the previous day. So it has clearly pointed out that it is a 5-day bootcamp and it has a 9 to 5 each day with breaks. Let's check out the information if it is providing me the right information or not. So yes, you can see that it is a 9 to 5 in-person bootcamp, and what it has, it is a 5-day 40 hours. So it is providing me the accurate results. Let's ask another question. So let's just ask, what are the prerequisites for this bootcamp? What is the level of coding experience that is required for this bootcamp? So the inference query would take a minute and I'll take some more questions. Will a link to this notebook be posted? Yes, I'll provide this notebook along with the slides and dataset. So the question is, any alternative for RunPod that is free? You can try Google Colab. There are a couple of quantized models that you can run on Google Colab. You can try Google Plus, like Colab Plus account as well. Okay, the starting, Adisek, what you're asking, how can I find the starting link? The starting link for RunPod. So it is here and I can share it. Yes, there is another question from Sai that yes, we are dropping. We don't fine tune a model on its concurrent 7 billion parameters. We do quantize our model first and then we train the model on top of it. So here is this answer. The level of coding experience that is required. Let me zoom it a little bit. Let me see if I can minimize this. So yes, no prior coding experience is required. Everybody can join. However, some basic understanding of programming concepts will be helpful to get most out of the bootcamp. We also offer pre-bootcamp foundation courses to help you get started. So it is the exact and accurate response. So after I have fine-tuned the Llama 2 model on my dataset, what I can do, I can deploy a chatbot over here. That can answer any FAQ queries that is relevant for my bootcamp. And I'll be doing that in a couple of, we can deploy this model into production as well because it is providing great response. So are there any other questions? I'll see it in the chat. So there is this question from Trading Indian. He's saying that I'm missing this question. Let me find out where is this particular question. How would you fine-tune a model to generate SQL queries on a large database of hundreds of tables with a few thousand fields, and how would you set up the training data set? So that's a very good question. And that is the particular use case people are trying to achieve. We have a lot of orchestration tools. We have Llama Index, we have LangChain. All of them are working with building some SQL agents as well. That particular agent would be able to do the SQL, would be able to write the SQL queries that are relevant to your own databases. So that's another interesting topic that we can dive into our upcoming webinar sessions. And this is something that this generative AI and large language models are enabling us to do that. So we can use orchestration frameworks, we can build some agents on top of it that can write SQL queries relevant to your own data set on your database. So I really like this particular question. how can I effectively integrate a large language model into my Android app or website to enhance its functionality and user experience? So your question is very relevant to our particular webinar. Let's suppose I have this particular, let me bring this screen and let me answer the questions over here. So if my screen is visible, let me start writing over here. So how can you integrate an LLM in your applications? You can do so. You can just utilize an open source LLM. You can use an open source LLM, fine tune it. You can either fine tuning or just use a RAG approach, retrieval augmented generation with a vector database, and you can do the inference queries in your apps. Now just use it into production. Use it into the production, and your customer satisfaction level would be increased. So that is something very doable. How large data sets can be used to fine-tune LLMs? Thousands, millions, and billions of documents. So Steve, this is a very good question. Let me explain you that. So let me just add a different slide. Let's talk about this. So large data sets. So for LLMs, we do have two things. Either we can go to the fine-tuning route, or either we could go with the retrieval augmented approach. We can use the RAG approach. So you have to find the sweet spot for your own use case. For your own use case, you have to find that sweet spot that either you want to go with the RAG approach or a fine tuning. If you have a huge amount of data, then using a semantic search engine and getting that into production would be more efficient. So it totally depends on the use case. So if you have data governance issues, if you have data privacy issues, I would suggest you to just go with an open source LLM. And this is a very open discussion. If I want to extract, so Krish has this question, what should be the approach if I want to extract certain information data from the user? Yes, you can use, if you want, like the context of your question is not clear, but what I am expecting is that you are trying to use the reinforcement learning with human feedback. That what ChatGPT does, it takes the reward function is under your hand. The reward function is totally dependent on the users, because once you get the response from this particular model, either you can upvote it or either you can downvote it. It cater out the reward function, and this is what we call reinforcement learning with human feedback. And sorry about my writing, because there are a lot of questions that are very, I really appreciate your questions, because every other question is a different domain that we can have a fireside chat, we can have a different webinar of 1 hour session on top of it. We can talk about reinforcement learning with human feedback. So this domain is very extensive and its use cases are also very extensive.